Hello. A couple of weeks ago, when I was coming back from visiting family, I noticed that there was a really incredibly intense sunset that day. And as I was looking at the clouds slowly losing their color, particularly the lower ones, I could see that there were two layers of clouds that day. The lower ones had already lost their color by the time I started to take these images, and it got me thinking if it would be possible to estimate the height of the clouds based on the time that the clouds lost their color. At this point, I noticed that the clouds were already turning or had already turned red for about maybe 5 minutes. And it was about this point where the lower clouds had lost their color and I was able to take these pictures safely. I had turned onto another road at this point, and I got another vantage point of the lower clouds being gray and the higher clouds above them still being illuminated by the sun. That's what the sunset looked like. And so I took a few pictures. And here I was approaching the main highway that was leading back into town. This one was probably about another 10-15 minutes later. And at this point, traffic was starting to get heavy enough that I didn't want to take any more pictures for safety reasons. At the very end, when I was still probably about 3 or 4 minutes away from my exit, I noticed that the clouds had pretty much lost the last of their color. So I created the spreadsheet in an attempt to analyze the position of the sun relative to my position and relative to the clouds to see if I could actually address my question of whether or not I could estimate the height of those clouds. So that was the date. And for each of these images, I went and extracted the metadata from those images to get the timestamps. Row 11 is roughly the time. This last one is an estimate of when that time was. It may not be exact, but I think it's going to be close enough for my purposes. I used Stellarium and marked my position on the map where I was when I took those various images. And after that, I dialed in the exact time and let Stellarium tell me what the sun's altitude in degrees, minutes, and seconds were. And then just for the rest of the calculations, I took degrees, minutes, and seconds, and I just converted them to degrees. I thought I would try to do something as well by using the right ascension, but it turns out I didn't end up needing that at all. And at this point, I tried to map in 3D space, or at least in 2D space, how high I would have been, or rather how far below the terminator line I would have been when those images were taken. And because light is being refracted through the atmosphere and it's curving, rather than use the geometric radius, I ended up using 7/6r to the radius of the Earth to get the equivalent radius of the Earth as if there was no refraction in the atmosphere. I was going to do a few extra calculations as well, which were not necessary. And so I ended up calculating the kilometers per degree that includes refraction, and this is going to be a value that's going to affect these columns over here. And so these are going to be a product of this sun's altitude with these kilometers per degree, which means that these are the number of kilometers beyond the terminator line. As I was analyzing the images and the data, it was a bit of a surprise to me that the sun had already descended almost 10 degrees below horizontal at that point, and even then there was still just a hint of color in the clouds. And by that point I knew that the clouds were no longer illuminated by direct sunlight, that it had to be done through light scattering. So I ended up finding the geolocation of the sun's GP for that time. This is my coordinate, and using the Haversine formula, I ended up calculating my distance to the sun's GP, including atmospheric refraction, by the way. So this is going to be a greater distance than the actual geometric distance. So this is what I was starting to suspect. If I was over here and I was looking up and the cloud was over here, for example, being illuminated by the sun, I was trying to get an idea of how many kilometers away from the terminator line I was and how many kilometers below the surface of the Earth that I was from that same point. If this, for example, is one coordinate, and as the Earth is rotating in this direction towards night, how many kilometers along this x-axis I was, and how many kilometers along this y-axis I was. This is just going to be a selector for one of these distances over here. And I did that because I'm using this value in these two cells over here. In all the equations, I'm using the 7/6r equivalent. And so if I take a quarter of the radius and I subtract that from my distance to the sun's GP, I can get the number of kilometers beyond the terminator line. If I pick this one, including an Earth's radius that compensates for atmospheric refraction, that would have put me at 12,601 kilometers from the sun's GP when I took this image. When I subtract the 90-degree arc, I get 926 kilometers beyond the terminator line, and then I'm able to calculate the angle in radians and then convert that to degrees, and this value is very close to this value over here. I use this angle over here to calculate my vertical component and my horizontal component. This was an extra calculation that I thought I would need, but turns out wasn't necessary. But just as an aside, this number should be about half the angle of this one. Finally, at the very end, as I was approaching my exit, by my calculations, I figured that the sun was 9.72 degrees below horizontal. That told me that I was 106.85 kilometers below the tangent and 1,255.8 kilometers further from the sun from that terminator line. And maybe this number really is useful after all, because that would be the slope like this. I would say then that 4.86 degrees happened to be the angle up towards the cloud like that, or rather probably the average angle up towards the cloud. Really, the big surprise that the analysis of that sunset told me was that the clouds are not by direct sunlight, but rather from the sunlight that is refracted through the atmosphere after the sun had set. So my next thought was that since the cloud is clearly beyond the terminator line and can no longer be illuminated by direct sunlight, it has to be illuminated by indirect light, or in other words, it has to be illuminated by the light that has to be scattered through the atmosphere. And considering that the light being scattered is scattered in all different directions, if the light is coming in this direction and it hits a particle in the air that then causes it to bounce off in this direction, or another ray of light that continues and then gets scattered in this direction from this particle, the light can be scattered in all different directions, so that the light that just skims the surface of the Earth has to travel all the way over here before it reaches a point where there is not enough atmosphere left to scatter the light. So I looked up how high the Earth's atmosphere is, and the basic figure given is about 100 kilometers above mean sea level. And I thought that it may very well have been coincidental, but according to when the last of the color in the cloud could be seen happened to coincide with a vertical height of about 106.8 kilometers like this, which makes me wonder if there is some kind of correlation that could be made in terms of the height of the cloud and the angle, which also happens to correspond to the practical transition between atmosphere and space, known as the Kármán line, for example. And this very well may be wishful thinking on my part, but if this is true, then I could be inclined to suspect that the higher clouds on that day might have been roughly 6.8 kilometers high. Of course, in order to be sure about this, I would have to take a lot more measurements and correlate what I see on those days as well to see if there's any difference in the time when the last of that color in the clouds can no longer be determined. But I thought that that was extremely fascinating, and hopefully you did as well. If you liked the video, I would appreciate the thumbs up, the subscribe, comment below, all that other good stuff. With that, I'm going to see you again in another video soon enough. So bye for now.